I am discussing first 15 questions of Grand Test 4 in this video. Remaining questions I will discuss in the consecutive video. Here, charge is distributed over two concentric hollow spheres. One is of radius r, other is of radius capital R. What he given is surface charge densities. Surface charge densities are same, that is sigma. Here let us say Q1 charge is on the inner surface, inner sphere. Q2 charge resides on outer hollow sphere. Surface charge density is charge by surface area, which is sigma. Q1 here is 4 pi r square sigma. Q2 is 4 pi capital R square sigma. So potential at common center, potential at C due to the charge present on the inner surface. Potential at center C due to charge present on this. Potential is KQ1 by R, KQ2 by R. So K into Q1 here is by R plus 4 pi capital R square sigma by capital R. Okay, here is 1 by 4 pi epsilon naught, 4 pi sigma if you take common, small r, capital R, sigma by epsilon naught R plus R. Your charged particle of mass m having charge q is released from rest. Let us take electric field. Force on this charge due to electric field is this. Started from rest. So due to the force due to electric field, the acceleration gained by this charged particle, so V will be 0 plus QE by m into T. So the kinetic energy here is half mv square. V square is m square into T. Q square is square T by 2m. So when electron revolve around the nucleus of a charge Ze, in order to excite in ground state, let us say energy, what it has is this. So by acquiring energy, it reaches to higher state. So that energy is 13.6 Z square 1 by n1 square minus 1 by n2 square. Give me a call after 10 minutes. Here it is 13.6 1 by 4 minus 5 by z square is 13 point, he given here 47.2 into 4.9 by this. It's roughly, it's not 4.9, 4 into 9. So here it is 13.6. How many times 13? 4 point something. Here 36 by 5. It's little less than 4. It is nearer to 7. So it will be less than 28. So perfect squares are given in the options. Z, you take it as 5. So metallic wire is folded to form a square loop of side A. It carries a current I and is kept in a uniform magnetic field, and it changes its shape to equilateral triangle. So here the amount of work done in this process is, so work done is this Q here, W here is, or this is VI for a small interval of time. So here V is nothing but EMF induced is minus d phi by dt. Your flux is initially its area, it's a square whose area is a square. Its area is root 3 by 4 b square. Change in area and perimeter, there is no change. Root 3 by 4, 16 a square by 9 minus a square. That is b into 4 root 3 by 9 minus 1. Here, so work done is in place of P. So d phi is nothing but B into minus 1 a square by dt into I dt. So which is how much it is? B into a square into I 1 minus 4 root 3 by 9. First option is correct. Moving in a circular trajectories kept in a constant magnetic field. So when charged particle enters in magnetic field, it moves in a circular path due to magnetic field. So here, force due to magnetic field on charged particle which provides necessary centripetal force. R here is, so he told kinetic energy is same, m square v square by 2m. So this is P by QB. P here is, so radius finally depends upon kinetic energy is same, kept in constant magnetic field, root 2 is constant. So radius of trajectory is proportional to only this. Proton is 2 and deuteron radius trajectory alpha particle. Deuteron mass is 2m, charge 1 is 4m, so which is 1 is to root 2 is to 1. Alpha particle and proton having moving in the same radius, but which is less than radius made by a deuteron. Here, two bodies A and B of equal masses, spring constants. The body oscillate vertically such that their maximum velocity. So velocity here is V maximum will be obtained when 0. Bodies oscillate vertically. Maximum velocities are equal. So since they are different bodies, right? Separate springs, separate spring constant. So omega is, but he told equal mass. So ratio of amplitude is here charge is AT minus current will be rate of flow of charge. A minus BT plus then the current at T0, I here is A. So I maximum means F dash T0 minus B plus, so time it is CT squared by 3 CT squared by 6. Okay, but time is B by 6. Here it made a mistake. Not C by B. So whether it is minimum or maximum, for minimum or maximum same thing. But if you find d square I by dt square, again differentiating, we get 0. This is nothing but minus B plus CT. 0 plus C. C here is he told positive constant. That means I is minimum. So that is I is minimum after a time B by C. A particle starts from origin, moves in xy plane with a constant acceleration in y direction. So y he given dy by dt is 2x dx by dt. So velocity in y direction, we told acceleration in y direction. So d by dt of vy is 2b. So here dx by dt, I will write dx by dt x if you differentiate. So once it has constant acceleration in this direction, so in horizontal direction its velocity is 0. So dx by dt whole square, that is ay 2b into v square. Here ay he given acceleration a. So v square is normal density of gold is this. So applied force here is so P bulk modulus minus delta P by delta V by V. Here pressure applied, delta P is small when pressure is applied, that is capital P. So K here is this. Density is equal to mass per unit volume. Density he given it as this, log increase in density of a lump of gold he is asking. Okay. So log rho is equal to log m minus, so delta rho by rho is equal to delta V by V. So bulk modulus in place of delta V by V, so he is asking increase in density, that is equal to P rho by K. The planet is revolving around a massive star of a circular orbit of radius r. So here, so gravitational force of attraction provides necessary centripetal force that is proportional to r power minus pi by 2. So here it is mr omega square is proportional to omega. M is also constant. So here minus 5 by 2 minus 1 r power minus. So omega here is 2 pi by t whole square. Means t square is taking the reciprocal time period. Square of the time period is proportional to, so r power 7 by 2. First option is correct. So when a body is executing SHM, kinetic energy is potential energy will be half into x square. At a distance of 1 by n, 1 by n of its amplitude from the mean position. So that distance is given 1 by n of amplitude. Your potential energy is this. Ratio of kinetic to potential is asking. So half k square to n square minus 1 by n square, half k square by n. Right, which is n square minus 1. Fourth option is correct. So in adiabatic expansion, product of pressure and volume, it's a theoretically good question. First law of thermodynamics. For adiabatic process, delta Q is 0. So delta W is minus delta U. So in expansion, volume increases. So work done will be P into P final minus P initial. That is minus delta U will be positive. Delta U is negative. So once delta U is negative, so U2 will be less than U1. So internal energy is a function of temperature. T2 is less than T. So ideal gas equation, NR is constant. So final value of P is nRT2. Initial value is nRT1. Final value of PV is less than initial value of PV. So that decreases. This particular problem, before solving the problem, I'll give little introduction about this Thomson experiment. Here, two plates, they kept at a distance, separated by a distance D. So this one is connected to positive terminal of the battery. This one is connected to negative terminal of the battery. So here, this is an electronic gun, which so electrons are ejected through it. So here is a screen. You can observe this bright spot here. When electric field is applied here, so negatively charged particle is deflected towards a towards positive. So here to see bright spot again here at the same point, some force must act downward direction. That force is due to magnetic field. So if I apply magnetic field perpendicular to the velocity as well as electric field, that is negative z direction, force on charged particle is, so particle is moving negative z direction, it's negatively charged. Here plus I cross k, force due to magnetic field act downwards, so that finally electron beam gets undeflected. That means force on charged particle due to magnetic field, which is equal to force on charged field due to electric field. So V here is E by V. Once external voltage V is applied, because of that electron gains a velocity. Here V is potential difference, here V is velocity. E by M here is V square by 2V. So E square by B square into 2V. When potential difference is applied, so here it is V square by D square B square into 2V. V by 2B square D square. So now E by M value is fixed. So once potential difference changes by 2 times, 2 constant D constant, how magnetic field strength changes. So that is here B1 square is B1 is root 2B. So here de Broglie wavelength for a particle which is moving with a velocity v. Here about gas molecule. So relation between kinetic energy. So each degree of freedom, it has half kT energy. For monoatomic in general, if you take 3 by 2 kT, m square v square by m. So p square is 3m kT. P here is here it is h by mv. I can replace with k. Here is Boltzmann constant, which is constant. H is Planck's constant. That is also constant, which do not change. So lambda is proportional to 3 constant m and t. Lambda 1 by lambda 2 is, since inversely proportional to both. So this you let us take for hydrogen, helium. So it's 4m. Temperature 273 plus 100. 273 plus 20, 300. 373 by 75. 75 roughly 5 times. Here it is 2m. 2.5. It is nearly 1.6 will be 2.56. So nearest value is this. Your electric field part, so it is E naught cos omega t minus kx. So obviously here wave moves along positive x direction, and omega is 2 pi into 10 power 6. 2 pi n is 2 pi. So n here is frequency. So x direction frequency. Wavelength v is equal to n lambda, and v here is omega is 2 pi into 10 power 6. K value pi into 10 power 2 into 10 power 8. N is 10 power 6. So lambda here is 200 meters. So second option satisfies.